Hello and welcome to this tutorial of installing Red Hat's OpenShift container platform on Azure using the UPI or User Provision Installation procedures. One reason why you might want to choose this installation over IPI or the Infrastructure Provision Installation is if your Azure team has pre-allocated a resource group that you need to build your OpenShift container platform inside of. So what we're going to do here is do just that. We're going to pre-allocate a resource group and show you just really how simple it is to do the manual procedure and just target that other resource group. Before we get started, we will need a Bastion host that will have access to that environment. It could be your local laptop. In this case, I just have a Linux machine that I use to interact with the platform. I will also need a few tools installed here. First tool is the OpenShift installer, and then we'll need the pull secret, which synchronizes our subscription details so we can pull down the OpenShift packages, and then we'll need the OC and kubectl command that will be bundled for this particular version. We'll also need the Azcli, and we will need the JQ binary. Now I will have all those links in the description below, but let's show you how to grab those. In this web browser here, we're going to cloud.redhat.com. And again, this is just to grab the Red Hat tools. So let's go ahead and log in there. We'll go to Red Hat OpenShift Cluster Manager, click that, and there should be a Create Cluster button here. Yep, there it is. OpenShift Container Platform, Azure. And then there's two methods here, Installer Provision Infrastructure and User Provision Infrastructure. We're going to pick User Provision Infrastructure, but essentially we just need the tools, so it really doesn't matter which one we're going to go to. We're just going to select that. I am on a Mac, so it defaulted to that, but the installer will require either Linux or Mac, so we'll go ahead and select Linux. We'll copy the link and just download that. We will need our pull secret. I've already copied this pull secret down, so I won't do that again. I've also actually already pulled down all the tools. I'm just showing you how to grab those. And then the command line interface support on Mac and Linux and Windows. I'm going to select Linux. And we'll copy that link. And then there's really nothing else we need as a part of the installation tools. And if we go back here and look at IPI, it's essentially the same thing. We're going to grab the installer, the binaries, and the pull secret. So we can just grab this one. Okay, the next tool we're going to need is the Azcli. I've already downloaded on this machine as well. So I've already logged in, and you'll just grab it here. And again, I'll put these links in the description. And we'll need the JQ binary. Depending on your Bastion host operating system, you could do a brew install. If it's Mac, you can do a yum install for the CentOS versions, and you can do typically an app install for JQ, or you can just fetch these binaries. I'm running the JQ binary 1.6. All right, so let's clear this. We'll look in the directory, we'll see our two installers. I'm going to remove those since I already have them installed. And just to help the directory look a little cleaner. There we go. So I've elected my install directory to be called Red Wagon. That's why you see that there. If you're playing the home game and want to follow along with the installation procedures, a lot of this is going to be contained under installing on the documentation, obviously. Installing, and then go down here to ARM templates. Right there. So we'll see pretty much everything we need to know step by step through the ARM templates. I will also put a link in the description on a script that I'll be going through so that if you want to do this install yourself, you can just modify the information for your environment and then attempt the install. Okay, so first things first, let's log into Azure. Az Login, and this will provide me with a URL. So I can log into my Bastion host here and provide this code. And my account. There. So when we log into our portal, we'll see I've already got a couple of objects installed here. I've got like Red Wagon resource group. I do have a Bastion host that's currently in there. We'll just leave all this alone. Everything that we'll create will be new objects referenced by the descriptor from the install procedure. You'll see that happen as we start moving along. Okay, so let's, we've already logged in here, so the next thing we really need to do is we need to figure out what resource group we're going to use. I'm going to use this Red Wagon resource group. There's no DNS associated to this yet, but I do have a DNS zone, this shifting red, and this one is actually in the in a separate. There's no DNS assigned to this. It's just a zone that I put in there. And I believe it's in the other resource group, this Red Hat OCP resource group. Yeah, it's right there. Okay, so that's fine. We'll target this as the primary DNS that it will use, and then it will create its own private DNS zone inside the Red Wagon resource group. All right, hope all that made sense. So the first thing we need to do is we need to create our install config. So OpenShift, OpenShift - install, create install config, and we'll target our directory Red Wagon. And I do have a public key on this host. If you don't, you can select none. This is a good idea to do. You can have multiple keys as well, but this will allow you to SSH into the Bastion host, which is handy for troubleshooting the installation. But it'll also be able to transfer this key up to all the nodes. So if you need to access the nodes, you'll have an account that you can SSH into using the core user. So it's important if you're doing the install, especially for the first time for a POC, go ahead and get a key up there so you can do remote access. And we'll select my key here. It's going to be an Azure install. It's going to load the credentials. East US is what I'm using. Shifting red is the domain. Cluster name, we'll say Red Wagon. Pool secret, I have that off screen. Give me just a second. There we go. All right, so we've got that in there. And if we go into Red Wagon, we will see, we'll go into Red Wagon. We'll see this install config file. So let's take a look at that. Our domain is shifting red. We'll create 3 workers. We'll create 3 masters. If you want to change the sizes of these workers and masters, you can make that modification here. The information on how to do that is contained within that ARM template documentation. I'm just going to, for this install, I'm just going to take the default network that's associated. In our previous IPI install, I showed you how that you can modify this. I'm just going to leave this all as is. The base domain group, or rather the resource group that contains the domain shifting red, that's the Red Hat OCP 001. And then of course my pool secret and my SSH key are also attached here. The region is East US, and we'll publish this externally, which means it will create the necessary records so I can have external access into the cluster. If you don't want it to do that, then you would change that to internal, and then it would not create those external boundaries. In that case, you would need to have like this Bastion host that's local to the machine, so that you can properly access and configure your nodes for deployment. Okay, so we're done there. All right, so I'm back out of directory, and then we'll do OpenShift install, create manifest, directory, Red Wagon, and it consumes that install file. So if you do want to keep that around, you'll want to go ahead and make a copy of that. So now if we look at Red Wagon, we'll see that there's 2 directories, manifest and OpenShift. And in manifest is where we're going to make most of the changes. We will delete a couple of the machine sets in OpenShift. But let's go into manifest first. Right, so we have this one here, the cluster infrastructure O2 config. We need to edit that one. Copy paste. And we'll see here that the infrastructure ID, this is important to capture. I will be using this as an environment variable, so let me copy that over. All right, And what this infrastructure ID is used for is all the artifacts that are created, including your nodes, will have this infrastructure ID tag to it. So it would be like redwagon-2vncr-master-1, etc. If you're the identity that it creates, it will have this dash identity, etc. So there'll be a lot of references to this, show you where all your how everything's grouped. Now we see here that we've got this new resource group that it's created. And essentially what this is saying, that when it creates the network elements, it's going to put them in this resource group, and then all the other objects will be in this resource group. Now you would change this if your VNet was going to be in a different location, etc. But we're going to actually put both of these in redwagon RG. So let's go ahead and change that. I'm going to copy this, and then we will just use the powers of VI. There we go. So we got redwagon RG, and save that. Okay, and then we have the DNS one right here. And we'll see right there. So again, we'll just do VI. All right, so the this is the private zone, so it'll create a private DNS zone inside of this resource group. And it's important to do this because what's going to happen is, as part of our installation, we're going to link this private zone to our VNet. So when the nodes come up, and they'll automatically create their own host names based on that infrastructure ID. It will link to the VNet, so that we'll be able to do name, or it will have name translation correctly. If at some point you want to make that even further to be manual, then after the installation is done, you can strip out the private access and create and convert everything to manual DNS. But for our installation, we're going to say that the private zone is within this resource group. The public zone, again, the shifting.red is in that other resource group, which is Red Hat OCP 001. And we have one more file to modify, which I believe is the cluster config, or it is cloud provider. I think it's cloud provider. It's been a minute since I've done that. There we go. So 2 resource groups here, and these are essentially for the VNets. So where the locations are for those the master and the worker nodes. So we will copy and replace these. Whoops. Search for that to replace with redwagon RG, both of them. There we go. And this is fine. This is just the network security group that will create inside that resource group here. All right. So that should be it there. We can, let's see, grep that, yeah, resource group here, and we shouldn't have anything. Okay, good. So now let's go into OpenShift, and we'll see that there are some machine sets already. This one is for the master nodes, and this is for the worker nodes. And essentially, we don't need these. We're going to be creating these nodes off of ARM templates, so we can remove those safely. We'll say here star.yaml, and this guy, the worker, star.yaml. And good. All right. And we also should not have any reference to the other resource group in here, and there shouldn't be any by default, but we'll just run it. Here we go. Nice and clean. Okay. So now we're back in our base directory, and we need to create the ignition files. So OpenShift, install, create ignition files, directory, redwagon. Whoops. Real-time people. Ignition config. No edits. Let's just run through that. This will just take a minute. Here we go. Now let's take a look at the install directory, and we just have some core files in here. We have our auth subdirectory. This contains the kube admin password and your kube config, so you'll be able to access it just by setting that environment variable. We'll do that here in a second. Our Bootstrap ignition file, we will essentially copy this up into Azure so that the system can boot and access it, so that it will bring up that system to install the master nodes. The master nodes will then synchronize with the Bootstrap server, get all their information, form their cluster, and then we'll join it with the worker nodes. And the only one we need to transfer besides the Red Hat CoreOS operating system is the Bootstrap file. These will be hashed and uploaded as part of our environment variable scripts. Okay. Now we're going to set some environment variables. I'm going to do that now and cut the video. Cluster name is red wagon, shifting red, domain resource group. Azure red wagon. Okay, so now we have some environment variables to drop in. The first, I'm copying this from my to-do script that I will link in the video for you. Export the cluster name. Cluster name is red wagon. We will export the region. I'm doing these one at a time just so you can see them as if you were typing them out. The base domain, which was shifting red, copy there. And then of course our base domain resource group, which was at Red Hat OCP 001. Caps don't matter, but my E does, so let me put that back in there. And then we have our infrastructure ID, which we copied down earlier, and of course the resource group that we're actually installing everything into, which is redwagon-rg. The last thing is our SSH key. I will be using that as part of the scripts as well, so that it will copy up the SSH credentials. So let me go ahead and export that. So let's export my SSH key equals cat home SSH ID RSA pub. Okay, great. All right, and then I think we're ready to get started. We've got our ignition files. Yep. All right, so let's go ahead and fire this up. I'm just going to refresh this browser. Okay, nothing in there. Nothing up the sleeves. So let's create an identity. In identity, we're going to assign the contributor roles to. And if you remember, we stored that infrastructure ID, and that's what's going to be right here in this element. And then we will, let's go ahead and export the principal ID, which is the identity principal ID. Copy that. And then we will do the same thing with the resource group ID. Okay. And now we just assign the contributor role to that identity. Great, clear. Now maybe it's popped in. There we go. So we have our identity, and you'll see here, here's the infrastructure ID, right? So I'm just pointing this out because you'll see a lot of elements that are created that will reference that red wagon 2VNCR dash whatever. Okay. Next thing is to create our storage account. Storage account is going to be used to transfer the Red Hat Core OS that we'll use to clone our machines, and it will also be used to store the Bootstrap ignition file. Okay. Then we'll export our account key. All right, I'm going to clear the screen. And then we will export the a variable for the URL for the image itself, and we're going to actually fetch it down. So there's a Azure image that we'll use to do the installation. You can also download the VHD file from Red Hat's website and upload it manually if you would prefer to do that. I'll show you this URL, echo VHD URL, and you'll see that it's contained within the Azure environment, or Microsoft environment. Okay, clear screen. All right, so now let's create a storage container. And I'm doing this all on CLI. You can obviously do it in the browser too. And then we will copy the image from that Microsoft URL into that container. And this will take a few minutes. I will pause the video and come back. You'll see it says pending. And we have a little while loop in the documentation you can run. And it'll just keep saying pending, pending, pending until it's succeeded, and then it'll end. So we will wait a minute, and I'll be right back after this has uploaded. Okay, so that's completed. Next thing we need to do is create a new container to store the Bootstrap ignition file. So let's create that container. Great, and then let's copy the Bootstrap up there. So we're grabbing it from the Red Wagon directory, Bootstrap ignition file, and we're just going to name it Bootstrap ignition. There we go. All right, I'm going to clean my screen. All right, so now we are almost ready. We need to provision the private DNS zone. Actually, let me refresh this browser page here for you. Yeah, let me show you the two containers. So if we go in our storage account, click containers, you'll see here's the VHD file. It should have created a 16 gig repository. Sure. And there's the VHD. You can upload it manually here if you want. And then of course the files, there's the Bootstrap ignition file. We'll export this so that when it goes to install, it'll be able to grab it. Okay. So now let me copy this over. We're going to create our new private zone inside this resource group. All right, so that's done. It's clear. And now, if we go back to our documentation, we'll see that there's some ARM templates that are being provided for us. Let's go take a look at this VNet. So creating the VNet, here's the ARM template, and we want to copy that down. We're not making any modifications to these. 01 VNet JSON. Of course you can, depending on your environment. Like if you're if we were installing this into a separate VNet and creating separate subnets, etc., then we would need to modify all of this. Also, when you go to do your nodes, deploy your nodes, the Bootstrap managers and workers, there will be a reference to the identity, and you want to make sure that you scroll down and find that and edit that as well. So VI, I can't remember if I copied it in because I was talking. Just check it. Yep, I did. All right. Okay, clear that. And now let's go ahead and we will deploy that template. And this will create those VNets for us. Okay, it's done. Clear the screen. We can refresh here and we should see a new VNet. Sure enough, well, here's our subdomain we created and our VNet is right here. So let's take a look at these. Let's take a look at the VNet. There should be two subdomains in there. There. One for the masters and one for the workers. Okay, that's great. Now, because we have our VNet and we have our subdomain, in order to do name resolution, what we're going to do is link those two together. I'm often asked about DNS, and in most of the UPI installs that I've done personally, it's been on VMware, where you have a DHCP server, so the nodes boot up using their MAC addresses, they will be assigned a name. For Azure, we're not going to do that. We do this link. So you have VNet that you created that the machines will be built into. They will be randomly named, again, using that unique tag that's generated. And then their DNS will be linked to the subdomain here. After the install, if you wish to go and change that, then there are procedures for OpenShift to strip out that link essentially, and you have then all manual DNS. Now, it's my personal recommendation to leave the link up because it allows you to dynamically scale nodes in the future if you so choose. If you did not and you broke that link and you were doing everything manually, then every node scale would have to be a manual effort. But if you have certain applications, let's say data science or whatever, and they're doing a bunch of jobs, sometimes it's handy to allow it to burst up to create temporary node resources, assign new containers, and run the workload. When the job is done, then all that can be retracted. Having this link will allow those resources to come up, join the cluster, and then scale as necessary. So let's build that link. Okay, great. And clear this. And what we'll do now is we'll export a new environment variable for the VHD blob URL. And this is for that VHD file. And then we will set up access to that VHD so that we will be able to export our image. Oh, we can do that after we go to fetch our other template. So let's go back here. And then we did VNet, which is right here. And now we need our image storage template right here. Let's copy that. VIO2 storage -JSON. Okay, no modifications to this either. There we go. Okay, let's clear the screen and take a look at our resource group here. And we should have exposed our image. And this is the one that we will use to clone. Okay, back to our templates again. And now we need to create that infrastructure. So we did our VNet, we did our storage, and now we need our network and load balancers. Let's grab that. Okay. All right, let's clear the screen again. All right, so now we've created our networks, or our load balancer rather, sorry. And we should have two. Yep, here's the public one and the internal. All right, so the public gives us external access to the API. And then of course the internal load balancer is so that all the nodes can communicate specifically on port 6443. All right, so the next step, let's export our public IP address that should be dynamically assigned by Azure. And then we'll add that to the base domain record as API. Copy, paste. So this will point API.redwagon in our case. And that will be added to our shifting red primary domain that's in the red-hat. The red-hat, let me see if it's that. Red-hat, shifting red. There we go. So this points to our public IP address. And let's go back to Redwagon. Okay, and then let's export the Bootstrap URL. This gives us access to the ignition file. And we will base64 hash that, which is required. And if you're on Linux, please make sure you add the -w0 to both the Bootstrap, the worker, and the master file. If it's not included, make sure you do that so it doesn't do any line wrapping. Okay, and now we just let's see our next step. Go back to our templates. So we've done all of that, and now we got to our Bootstrap machine, which is 04. Again, no changes for me here. For bootstrap.json, paste. And here here's the default one that's being created, but if you need to adjust it for resources or whatever, here's all the allowed values. There's plenty of machines that are in there. And I did point out earlier that in order to do that, there potentially is variables that need to be changed. One also being the identity, but also if you're messing around with those networks, then here's the VNet, master subnet name, and those will be required for this installation. Also, if you're doing any other edits to it, definitely browse through these install files. It will have complications if these aren't edited as well. All right, so now we've got that. Let's go ahead and deploy our Bootstrap. Paste that. And we'll jump back over to Azure. And if we refresh, we should start to see Bootstrap resources come in. This usually takes just a few minutes, and when it completes, it'll just drop to it'll finish the prompt, kind of drop to a success end, and then we'll be ready to deploy the masters. Usually this takes 2 to 3 minutes on Azure. Here's the Bootstrap resources coming in here. So we got the VM, the network, our public IP address, so we can SSH into it primarily, and then there's our disk. Okay, so this will just take a couple of minutes, and then we'll check things out and deploy the master. Okay, so it's completed. It's only been a couple of minutes. That's good. So let's take a look at things. Just refresh this, and we'll jump into our Bootstrap and click connect. And essentially what I want to do is I want to see if we can SSH into it, show you how that works. All right, so we'll just do SSH I. There, and notice we're switching to the core user. All right, great. And we can run sudo cryctl ps, and we should start seeing containers come up. There we go, great. So Bootstrap's on its way. We'll exit out of that, clear. Go back to our resource group. And then from here, I'm going to deploy the masters. So, again, I'm just making a change to my script here. Exit. And we will paste. So here we are, again, using that base64 -w0, and we're hashing out, or encoding, rather, our master ignition file, and we're going to export that as an environment variable. Great. And now we will deploy it as 05. So let's go back to our documentation. And master machines, also referred to as control plane machines. And again, not making any changes here. 0.5 masters JSON. Paste that data in there. Great. And we will deploy them. And this takes roughly about 10 minutes. Oh, was I not in there? What did I name that? 05 master JSON. And my script says 05 masters. Got it. Typo. This is why it's good to write it all out first. Master. There we go. And we'll jump back to right wagon. And let's see if I refresh here. Again, I was starting to say it takes about 10 minutes or so on Azure to run through this script. It will take a little bit longer, obviously, to build all the nodes, get all the containers downloaded and synchronized, and bring the cluster up. But this should be the last major step before the workers. And the master NICs are coming up. All right, so great. I will let this speed ahead, and I will be back to you once this finishes, and then we'll run our wait script to make sure that the installation finishes. And once that's done, we'll start rolling forward with the worker nodes. Okay, I'll be right back. Okay, that's completed. Only took us a couple minutes to get there. Let's clear the screen here. And then let's refresh. Scroll down, and here's our master 0, master 1, master 2. That's great. And if we jump into the VNet, this one, VNet, and here's the nicknames that are associated to their internal IP addresses. Okay, back to the resource group, refresh. Now it will take a few minutes. On Azure, I've seen it move along pretty quickly. So like 10 minutes or so, we're gonna log this. So essentially we're just running a wait for Bootstrap to complete. And the Bootstrap means that those master nodes are coming out, forming a cluster, pulling all their configuration information from that Bootstrap, temporary Bootstrap node we installed. And then it'll print out that it's ready. So let's click that. What did I do wrong? Oh, yeah, sorry. I'm including all the errors I'm having as an install as well. I don't want to edit those out because it's real time. So just how it really is. We always make little typos, so I think it's kind of important to see that not everything is perfect. So it looks like the API is already up. That's good. And now we're just waiting for that Bootstrap to complete. Again, this process is the master's coming up, pulling all their configuration information from that temporary Bootstrap node and bringing it up the cluster. Once this is done, it'll drop out, and then we can check the cluster status before we start to bring up the nodes. Again, this usually takes about 10 or so minutes on Azure, but we'll do a time check. It is Sunday, 1:16 p.m., and we'll see how quickly this finishes. Okay, there we go. As you see, the elapsed time is about almost 7 minutes. Let's do a OC get nodes. We're not logged in yet because I did not export my kube config, so let's do that. OC get nodes. Great, so we have our master nodes, they're up and synchronized. At this point, we could go in and remove the Bootstrap stuff. Go back to our documentation. There is a little quick script to strip all that out. To copy, paste. Okay, so that's pulled all the resources out. We know it no longer has access to the blob store, so that's great. All right, and then let's go ahead and export the worker ignition file. Again, make sure you add that -W0 at the end on Linux. All right, and clear our screen here. And now we need to grab that other template. So we'll just go back and we'll look at the worker node machine. So here's the ARM template for the worker nodes. Again, no changes for me for this demonstration. We'll just do 06 underscore workers JSON, paste that in. There we go. And we will, whoops, we will hopefully not blow things up. It's clear. All right. And we will run the worker script, paste, enter. Okay, so that's done. Clear. And let's do OC get nodes. We should have the 3 masters. We do. And then we can do OC get nodes. OC get CSR because we're doing this manually. CSR. So we have to approve the certificates generated by the worker nodes, and we'll rep pending with a capital P. Nothing yet. All right, so let's just watch that. Rep pending. All right. So we're expecting the worker nodes, when they come up and load all their containers and try to connect to the master nodes, they will present a certificate signing request, and then the master nodes need to approve that signing request. And that'll happen twice, and then that will permit the masters then to join the cluster, or sorry, the workers to join the cluster, and then we'll have 3 nodes that are master nodes and 3 nodes that are worker nodes. Okay, looks like we got 1 pop in. There should be another 2. There's 1 more. Okay, there we got all 3 nodes now. So let's do OC get CSR, rep pending, then OC ADM, certificate approve, and then we'll grab these 3, copy paste, copy paste, copy paste. All right, OC get CSR. It will happen twice. Yep. Pending. 1 more. There we go. So OCDM certificate approve. Copy paste. Okay, great. Everything's approved. Clear. And now we can at least check the status of our cluster. Just do OC get CO, which is for the operators, cluster operators, and we'll see that things are starting to build. It will take a few minutes. What we're looking for now is this console. So it's still progressing because the worker nodes were just joined. So a lot of these resources have to build on the worker nodes. So we'll wait for that to complete. Once the console is done, we'll jump in. There's a couple of areas we need to modify for that to add the resource group into the credentials for Azure, and then we're done. So let's give this just a couple minutes. Watch. Let me do a grep here. So watch OC get CO pipe grep console. And what we're looking for is to this unknown to say true. Okay, so it looks like the console is done. Let's go ahead and close that. Clear our screen. We see OC get projects, grep console. And we have a console operator and the OpenShift console. So OC get route. Switch to the namespace, OpenShift console. That should give us our route. All right, here we go. So let's copy that. We'll fire that up in our browser here. And it is using a private cert, so we do expect this. Visit website. And of course I'm on a Mac, so I gotta approve it every single time. Visit the website, yes I mean it. All right, and then kube admin. And if you remember that auth directory here, so it's cat, red wagon, auth, kube, admin, password. Here's our temporary password. Copy, paste, login. Not save password, that didn't work for some reason. Kube admin, did I not type that right? That looks right. Paste, not now. Great. All right. So it's still bringing up all the cluster resources, but we can go ahead and make some changes here. Go to workloads, secrets, all projects, and just search for credentials. These are the stored credentials. And our resource group is the Redwagon RG, and this will have that dynamic resource group assigned to it. So edit secret, scroll down, we'll see the dynamic resource group, and here we need to say Redwagon-RG. Save. And then go back 3 times, 1, 2, 3, and grab the other one. Credentials, edit, secret. So there'll be 4 of these. Redwagon-RG, save. 1, 2, 3. Cloud credentials, edit secret, scroll down, RG, only 1 hyphen, save, 1, 2, 3, and our last one, edit secret, scroll down, RG, save. I'll scroll up here to the top, go to overview, and all this will need to get rebuilt again. So it's in the process of finishing. We can see that by going to OC get CO, which is the operators. And we've got a couple of things that are still trying to build. The image registry, we needed those keys stored in here so that the internal registry could be created. And we'll also see things like the API right here. These will kick off now that it's got the new credentials. These will be rebuilt. So let's do OC, or watch, OC get CO. And see, they're starting, the controllers are starting to be rebuilt. Our image registry is finally up now that it has access. Everything's looking pretty good. So just give it a minute, and when all this is done, you'll see all these go green right here. Okay, there we go. Everything's up and running. All the operators are running. Let's go ahead and stop this. Clear. And it looks like we are at version 4.5.13, so a few details. And if we wanted to right now, we can just go ahead and roll up to 4.5.15, and that's what we're going to do. So in order to upgrade your system, just go to Overview. It'll tell you that there's an update available. View updates, select the update you want. And if you want to look at more edge type systems, you can go to Administration, Cluster Settings, and you would change it here. So if I wanted to look at fast, stable, or any of the candidates, I could do that and then elect it to roll up to that version. Here we'll just say, yes, I'm going to take 4.15, click Update, and now I'm done. We can go back to Overview, and you'll start to see the, let's take a look at the operators, and these will start being rebuilt. There we go, cluster's starting to update. We can actually scroll down here, and I can show you that. Cluster operators, here we go. We'll start to see these roll independently to 4.5.15 as they're being updated. Which one's updating now? Let's see. I guess it's still downloading the packages. So it's in progress. There it is, 1%. That's it. So this will just take a few minutes for it to upgrade. I'm not going to go through that part. We don't need to wait any longer. I don't know how long the installation took us. I will try to put that the time in the video here. But we do have a healthy cluster that's up and running and ready for next steps, day 2 operations. Just as a side note, you do want to maintain a healthy cluster for at least 24 hours so that the first key internal key configuration can cycle, and then you'll be ready to go. So we're good here, and I hope this video was helpful for you. Leave any comments below in the description. I'm happy to provide additional information if you need it. Thanks.